Apologies for getting started just a little late today. It's been kind of crazy down here. We're without power, water, internet. So I'm going to be doing this edition of Helium Hacks Happy Hour from the car. I've got a power inverter and hopefully things kind of hold out. I'm backhauling off of my phone. So didn't have music this week. Sorry about that, folks. But next time. It's been a day. But welcome and thank you everyone who is able to join us today. I go by TTG on Discord, and if this is a very casual call, if this is your first time, I just want to give you a little background. If you can go ahead and mute your mic if you don't want the floor, and it makes it a little bit easier on everyone. But if you do want the floor, that being said, feel free to unmute and jump in at any point, and we want everyone to have a voice here. We have a very special guest with us today, Professor. He's our VP of Engineering over at Helium and is going to do an AMA. I know a lot of people here are very excited about that. And so if you have tech questions, if you have something you want to know about the Helium Network, this is the man to ask.
Andrew, maybe you want to do a little introduction to sort of open the floor for questions?
Yeah, I'm Andrew Thompson. I'm the VP of Engineering at Helium. I've been at Helium for many years now. I think this is my 6th year, or will be my 6th year at Helium. I joined Helium when it was a very small company. I think there's only 3 people that were at Helium that are still at Helium from when I joined. So I've been there, through a lot of pivots and stuff like that. So it's kind of interesting to see a lot of the original ideas that Helium was founded around actually come to pass. We took a lot of detours along the way. Before that, I was at Basho doing distributed databases. Before that, I worked in the voice over IP industry. I did a year at Barracuda Networks. And before that, I did other voice over IP stuff. So I've done a lot of networking and sort of database stuff in the past. Which, sort of, I guess, set me up relatively well for this kind of excursion.
Cool. Maybe tell us a little bit about your direct contributions, I guess, if you will, to sort of the evolution of the Helium network. Are you taking it to current day? Like, are you directly involved in some of the validator stuff, or you sort of think?
Yeah. So I'm Vagabond on GitHub. So you'll see my fingerprints over a lot of the repos. I built the original. Well, I wrote 2 or 3 blockchains before we got to the one that we have now. I wrote a lot of the original bits and pieces. I worked on the consensus stuff, the cryptographic stuff, the distributed key generator. I was probably I wrote a lot of the early blockchain stuff. I've been doing a little bit more of some more research stuff lately. So validators, I'm reviewing that PR right now for Evan, but I haven't touched it. I discussed it with him, but he's led most of the implementation on that one. But a lot of the other stuff, you'll see my fingerprints all over if you go look at GitHub. So yeah, I spent a lot of my time on the blockchain. I also did a lot of the original libp2p work. So a lot of that stuff I've done in the past. I've also done a bunch of embedded development for Helium, not in the current stuff, but previous embedded stuff. So I'd actually love to get back to doing some embedded stuff on the Helium network. Now we actually have a real network, but hasn't been time for that yet. But yeah, so and then in the distant past, I did a bunch of UI stuff for Helium on a previous product. So I've done pretty much the full stack here at Helium. Oh, also, I did a lot of work on the firmware image that we shipped to the hotspots. I did a lot of kernel configuration wrangling and system scripts and all that stuff. So,
Andrew, I was wondering if I was starting a software program and I was putting it together, in your experience through working on blockchains, and I wanted, would you go the blockchain route or try to go more centralized route for gamification? Let's say if my app wanted to do gamification type things instead of putting it on a blockchain, would you suggest maybe more centralized server or something like that?
yeah,
like, what's the real benefits, or is it
yeah,
that difficult? Like,
yeah,
is it
yeah,
worth
absolutely.
the headache?
No, that's a great question. So you should absolutely not do a blockchain unless you have convinced yourself that there's not a great alternative. They are big, slow, complicated, fiendishly complicated at some points things. And if you can consume a blockchain as a service and that makes sense for your application, that's great. But we are still learning how to build these kinds of systems, right? I mean, there's a huge amount of innovation happening in this field, right? We discovered sort of this area of computation where, like, you have a whole bunch of things that don't trust each other. Can they work together to get something useful done? We discovered this back in the 1980s, and then nothing really happened for 30 years, and then we're sort of in this resurgence of the idea that centralizing everything is a bad idea because you cede a lot of control and ownership to a central party that may not have your best interests at heart, right? I mean, I think the backlash against Facebook, for example, is a great example of this. We're realizing that it's super convenient that Facebook has everything you want, but the fact that we killed all these little forums and IRC channels and email lists and stuff like that to get there now means that it's very hard to get rid of it again. And so we've seen this swing back away from centralization, which I think is a good thing. But the technology is definitely it's harder, right? You have to. It's very easy to build centralized systems, which is why we spent a lot of the last 30 years building them, right? The original internet was very decentralized. Everybody ran their own DNS server, and the DNS servers talked to each other. Everybody ran their own email server, and the email servers talked to each other. But the problem with that is they built it in a context where everybody trusted everybody else. Everybody's like, well, all the other universities on the ARPANET are going to be honest actors, and so I don't have to worry about the other university doing a bad thing, right? I'm assuming good intent. And as we learned, in the 90s and the early 2000s, that doesn't work. As soon as you open the internet to, like, everybody, right? A bad actor can do all kinds of bad things. This is why we had such a problem with spam. We have a lot of these issues, BGP hijacking, all of these systems that were initially designed to be to trust the other side don't work. And so we went to this, okay, let's centralize everything. Let's give Google and Facebook and Apple and Twitter all the key, we'll trust them. They'll do a good thing. We had 20 years of that, and now people are like, well, that isn't great either. Let's try to move the pendulum back the other way. But back to your original question, I think that the reason that you use a blockchain is that you want to build a system that sort of democratizes ownership, or like, let's, one of the big things we wanted to do when we came up with this idea was, we talked to customers and they'd be like, well, everything you're showing us is great, but you're a tiny startup in San Francisco. Like, we can't rely on you to be around in 10 years. Like, we can't build our business on you. And so what happens if Helium goes out of business, right? And this was I heard this a bunch of times. And so, like, the idea that Helium is integral to the network, and that if Helium goes away, that network stops working, right? You get the incredible journey, blog post, and all of our services will be shutting down in a month, right? Like people don't like that, right? Like, they really don't like that, especially when there's a hardware purchase involved. And so, we really wanted to build a system that didn't require helium to exist. Obviously, I want helium to exist, but from a like, you can use this network and have some confidence that your hardware will continue to work. Like, we needed to build it so that this wasn't, we were not, the spider at the middle of the web, right? Everything didn't have to come through us and then go on to something else, right? We wanted to build something that looked much more like the early internet than we wanted to build the Facebook of IoT, if that makes sense.
Yeah, and see, so that's what kind of chases people, probably moves people down the blockchain route. In my case of my example of a software program, that if you got, instead of me building a server and then I got to bring in content, I'm a filmmaker in general at heart, but in general, you have Netflix and then they got to get all this content, but if you can get the content from the people, that will be really great, right? So then if how I envision is that the blockchain is the only way to solve this problem and live even after whatever my program is. Is that a good example of why somebody might then say, I do need a blockchain then? Even as a shortcut though, you see how the shortcut is just slightly? Because then you get the content from the people. And if it just kind of runs, organically from the people, you get the content from the people, right?
Right. Yeah. I mean, if I would just caution that we're not entirely there yet, right? That we're still really learning as an industry how to build systems like this. And so, it's definitely, and there are not a lot of people with a lot of experience in this field. There are a lot of things that you have to sort of learn not to do. And so, I think that that's absolutely the way we're going to see things moving in the future. But we are really in the midst of like a big sea change in this industry. And so having built a blockchain, like I still believe in the reasons we did it, but it's an extreme choice, and it causes a whole bunch of other stuff to become much harder, partly because we just don't have the libraries and the cryptographic primitives and the networking primitives that we need for this kind of setup, right? I mean, we had to write our own networking stack. I didn't want to, but we had to. We had to write it. I implemented a ton of cryptographic stuff that just, the papers are there, but nobody's taken this academic thing and turned it into a workable, software component, right? So it's getting better, right? It's a lot better now than it was 3 or 4 years ago, but we're still really building the fundamental pieces that then you could put together to make a system like you're talking about.
So if you were hiring a software engineer, they would run into a roadblock of knowledge that could happen because there just isn't information out there to solve the problem of the issue that might, or the thing you even want to do for them.
Yeah, absolutely. Oh, absolutely. I mean, we've had to come up with countless solutions to problems. Like, nobody's ever built a network like this before, right? So we're learning, not only what works, but what doesn't work. And this is definitely a thing. Like, nobody's built something quite like this before. Like, this whole idea of a network deployment and the way that the network works is really, like, there's no book I can go read or web page I can go look at that's going to give me the answers to, how do I solve this problem?
Yeah. So you, as an engineer, in the sense that, would you say that in hiring or trying to find the perfect or the right fit of a blockchain developer or whatever, that is more about maybe even being creative than even maybe the actual super skills of things that they might have learned previously?
Oh yeah, absolutely. When I'm looking for somebody to hire, what I'm really interested in is not really their work experience. I'm never going to find an engineer that has the background that I need, right? Like we're not building a WordPress application or something that's a commodity, right? What I look for are with people who are they're curious, they're creative, and another thing is they don't give up, right? You know, like I can't count the number of times that I've almost given up on something, or I've seen people give up on something and they were, you know, right next to a solution and they got frustrated and they threw it all away. And I'm like, no, you had it. You just had this one thing wrong. And like, you know, it's sort of the superpower can be, I'm too dumb to quit, right? Because if you, a lot of times, if you haven't proven that it's not possible, you don't know it's not possible. Just because you haven't gotten it to work yet doesn't mean, like, you know, sometimes you really have to explore all the dead ends to be sure that this doesn't work. If you just give up, you don't know, maybe you were 5 feet from the answer, right? And so, like that's a big thing, is just don't give up. Prove to yourself that it's impossible before you say it's impossible, right? And I think, like a lot of things that we've managed to do at Helium, people 2 or 3 years ago told us were impossible, right? You know, it's not possible to create a giant LoRaWAN network in the United States. We're now the largest LoRaWAN network in the United States, right? Not we, but all of us together, right? Like there were so many things that people said, like, this is not going to work, you can't do this. And sometimes they were right, but sometimes they were wrong. And they, you know, like the important thing is you should try until you're convinced it's not possible, and don't give up too soon. Because
the topic of the on bringing it back around to sort of Helium and the network, Frank was alluding this at the top of the meeting, the idea that the Helium network is, you know, not just LoRaWAN, and instead we can start thinking about cellular networks or Wi-Fi networks and things like that. I've seen a lot of that conversation, I think, but it might be interesting for some of the other folks here, just if you can talk about maybe some of the challenges that are going to exist in the pursuit of those types of networks. Just, what gets you excited about it?
Yeah. No, I mean, that's like, it's something that we've bounced around for a long time. We just haven't had the bandwidth to really address. But yeah, I mean, it'll be, you know, there are some interesting differences, right? Like LoRaWAN is very packet oriented, right? It's basically, here's a message, it's all framed like this. It's like a one-off thing, right? But if you're dealing with Wi-Fi or 5G or something like that, right, you're now dealing with a stream of data. Maybe you packetize it into 1 megabyte chunks, or, you know, how exactly do you want to, you know, what are you paying for, as like are you paying for data? Are you paying for discrete packets? You know, like how that gets bundled up. There are also some interesting things around, like these are all very different protocols, right? Wi-Fi, LoRaWAN, 5G, they are all extremely different. I mean, 5G is, you know, like an enormous protocol. Wi-Fi is more or less understandable as long as you stay away from some of the crazy stuff. But yeah, I mean, fundamentally, the Helium blockchain doesn't care what you're buying and selling, right? Like it is basically, I paid for a thing, you got money for doing a thing. And so it is sort of already extensible to exchanging other kinds of data or whatever. And we just hope to extend that, right? I hope that somebody comes to us and says, I want to do wireless on the Helium network, right? I mean, ideally, you have a gateway that does LoRaWAN, it does Wi-Fi, and it does 5G. And then, you know, you can do longer range sort of networking stuff with the LoRaWAN stuff, so we can still kind of figure out how things all connect together. But then those are also providing like regional data coverage. And then, you know, you have to deal with things like, how do I roam on this network, right? You know, roaming works differently on Wi-Fi and on 5G, but like the idea would be, it should be seamless, right? You should have some way to connect to the nearest base station or whatever and get your data up and down. But like, a very dynamic routing network is interesting because, cellular does this, but Wi-Fi is not great at roaming still. I don't know if you've experienced this. At least depends on your phone and your base station. Sometimes it works fine. Sometimes it's getting better, right? It's a lot better than it was 5 or 10 years ago. But there's just a lot of the devil can really be in the details on some of these protocols. Like, how exactly do you map this through? Like, how do you authenticate to the Helium network? How do you say, as a phone, this is how I'm going to pay for my data, right? Or who's paying for your data? Like, are you paying a cell phone provider and they're, like, how all the mechanics of this are interesting, and the way that all has to fit together, I think is going to, like doing it with LoRaWAN, we learned a bunch of stuff. So, I mean, whenever we see, as we see these new protocols come online, we'll probably have to solve some additional problems around, like, how do you transform a protocol that doesn't have this notion of this kind of network to support this kind of, like, rewarding the base station directly, and not it just being a fleet of AT&T cell phone towers or Wi-Fi in my house, right? These are, like, economically, the fundamentals are very different, and you have to surface those economics in the protocol at some level for it to make sense, or you have to extract them from the protocol.
I'm guessing gone are the days of the custom protocols.
Yeah, no, unfortunately.
LoRaWAN ended up being the winner.
Yeah, LoRaWAN's the thing, and LoRaWAN isn't a perfect fit itself, right? We've had to definitely do some contortions to get it to do what we want it to do. It's just probably the most adaptable one because it's relatively simple. The spec has its warts in it for sure, but it's nothing like a Wi-Fi or a 5G. So it was sort of it was the most underserved market, right? Like, that was the one where there just wasn't a good IoT network in the United States, open access one. Like, you had things like Senet, and I think a few, like a Machine Q was there for a while. I guess they pulled back, but, like, there's still not a good, and Europe has this solved in a different way, although maybe not as well, but, like, maybe it's not perfect out there. I don't have as much experience over there, but, like, the US definitely had a massively underserved segment for, like, we just need an IoT network, right? We want something that is cheap and can run on AA batteries for years at a time, and you can't do that with cellular, you can't do that with Wi-Fi. Even still, right? We've heard all this Cat M1 stuff is, it still doesn't seem like it's really happened, or NB-IoT, like they're still not sure. Maybe they're finally here, but it looked like the carriers were going to screw it up. So I never underestimate the ability for the carrier to screw something up. So obviously this was the easiest one, and it was the one that would, like, have the biggest impact compared to the others. But I think that absolutely we should do other wireless protocols on top of this thing.
Yeah, that'll be exciting. There's a question in the chat that I'll see if you want to talk to for a little bit. They were wondering about building messaging networks sort of on the Helium network. I don't know if you have any ideas around that. I know that's something that Travis has played with a bit.
Yeah, I have, like, in my mind this perpetual toy I want to make, which is basically something very similar, where you do like a strongly encrypted group chat on a blockchain kind of thing, right? And you join, and then it runs a distributed key generator. Everybody gets a new key. Everybody gets the new key, and then you're in that channel because you're part of that. You have a shard of that key. You can send and receive messages. Nobody else except people in the group can see those messages. That would be really interesting. If you want to do, I mean, I guess it depends on who you want to message and why. A big problem with putting, and I was talking about this at work today, actually. A big problem with putting, like, user-generated data on the blockchain is that you can run into a lot of trouble with, like, government jurisdictions insisting you censor that data, and because it's a blockchain, you can't. And so, for example, some countries have laws that you can't insult the king, right? So imagine somebody gets on the, and sends a message that says, the king of country X is terrible. And all of a sudden this country comes to you and says, you have to censor your blockchain. And I'm like, what do you, I can't, that's it, but governments are still more than happy to ascribe ownership to something, like you're still the figurehead, right? You're still the go-to company. And so you don't, you have to have a really good story for that, right? You can't, it's not like Twitter and it's not like Facebook. You can't take it down, right? That's not really, so you have to be careful about that. I mean, there's also, you in general, we've seen that having, people having access to chat in an anonymous way can lead to like really bad behavior emerging. And so again, it's like, do I want to build this thing and then it become, full of questionable content by people who have nowhere else to go? And I think probably the answer is that, like, you probably should just build it because, but yeah, like there are people doing it, like the open privacy people are building a completely anonymous chat system, and it's, it's just like there are sort of, do I want to be responsible for that? And do I want to potentially be held responsible for that is a question. So these messaging things are really interesting. It's just like legally really is the problem here. Do you want to have to sort of own all of that information? And I think the jury is still out on that one.
Right. I'll try and open this up if anyone else has some more questions. Otherwise, I'll try and we'll keep you moving. I'm sure there's plenty of validator questions we could start throwing at you.
Oh boy.
Andrew, one thing that a lot of people don't have a lot of understanding about is sort of how POC works. I know it's something, well, I know that's what you worked on. But like, could you tell people, like, why did we start with multipath, and then like what has changed recently with beaconing and sort of like how that thing works? I think people would love to hear about that.
Oh, that's a spicy topic.
Yep.
Okay.
I bring the hits.
Well, I mean, you're gonna have to, now you have to listen to my answer. Okay, so you have, in something like Bitcoin and Ethereum right now, you've got proof of work, right? You effectively what you're doing is you are parlaying some scarce commodity into an identity. So while a miner is mining Bitcoin, it can't do anything else. It's using all of its capacity, right? So I have a computer, or I have a whole shipping container full of computers, whatever, right? I have a mining pool. And that mining pool can mine Bitcoin, or it can do something else. It can't do both, right? And so that sort of is how Bitcoin extracts an identity, a costly identity out of its network, right? With proof of stake, you just, you push a pile of gold onto the table and you say, like, I'm staking this gold can't go anywhere else, right? Like it's now being staked for this thing. And like, I'm building my identity out of gold or a scarce token, effectively, right? And because that, again, it can't do two things at once, that's a proxy for an identity. We wanted to try to do something a little bit different. And so, there are, if you think about how radio waves work, right? They have sort of scarce things associated with them, right? If you do a radio transmission, it does not go infinitely far. and the power of that transmission degrades over a distance, and you can't transmit from a place you are not at, right? So we sort of are trying to parlay geography into an identity system, versus doing, hashing numbers or proof of stake. So that's sort of where POC came from, and we've had our ups and our downs about getting that right. I'm doing work on it right now. Again, there's no precedent for this, so we're definitely to a degree learning on the fly. We had some original radio restrictions that were capabilities that we no longer have, and so we've had to adapt to the hardware changes along the road and that kind of thing. But fundamentally, that's the goal of POC. And originally, obviously the packet was an onion packet, and so each hop you decrypt a layer. Each hop would have a target. Only that target could decrypt the packet. Then that target would broadcast on again, and vice versa. Basically, beaconing is a degenerate case of pathing, right? Instead of it's the last hop. Basically, you get the packet, you broadcast it. Anything that sees it is a witness. The reason that we took out pathing is sort of, I still think the nice thing about pathing is it lets you interrogate a larger area in one shot. The downsides of pathing are that if you don't path very well, the path can die. Also, if the pathing packet is larger because it has to contain more information to support getting all those layers in it. And so to sort of simplify things, we took that out. Maybe it'll come back. I secretly hope it will, but I have to make that case. But basically they're similar. You also sort of had a little bit more information about the transmitter in the case of pathing, because you know that transmitter not only can transmit, but it also had to receive. And so with a beacon, because there's only the transmitter doesn't receive the packet, it transmits over the radio. You don't actually know that radio can receive in that location. So there's it's okay. It degrades gracefully to that case, which is fine. But I think and it is simpler and it does work a lot more reliably. But I do hope at one point maybe we can do something a little bit more sophisticated again. Maybe not pathing. Potentially a POC challenge is actually a set of packets transmitted around a network, and nodes that can see all of the packets together can witness, right? And so you're doing like a network challenging for multiple pieces on the network at once. Something, again, I'm playing with a bunch of different options right now. I don't know if that answers your question, Abai.
No, I think that's great. Can you tell people what the difference is between a challenger, a challengee, a witness, like kind of?
Oh yeah, sure. Okay, yeah, exactly. Okay, so hotspots, they because they were added to the network, they have basically a golden ticket every some number of blocks, it depends, that they can say, okay, I'm going to cash in my golden ticket and I want to do a challenge because I want to earn some money. That challenge, they provide a piece of entropy, which is a piece of random data that only they know. And then that challenge appears on the chain. And entropy from the chain where that challenge appears and the local entropy are combined to generate who you're going to challenge. And who you're going to challenge is called a challengee. Challengee is a hotspot that we think is alive, right? It's shown some activity recently on the chain. It's probably done a challenge itself. And so we know that it's likely to be online, networking and other issues being, you know, on a network this large, the network is always broken in some way. So, you know, you can never guarantee that it's going to actually be accessible from where you are. There could be a shark chewing through an undersea cable right now, and you can't get there from here. But basically, you don't get to choose who you're challenging. A combination of your local data, your local random data, and the blockchain's local random data is combined to generate the entropy used to construct the challenge. You are then given a challenger, or you as the challenger are told, here's your challengee. You construct a packet for that challengee to send. You send that challengee a packet and say, hey, here's a packet for you to send. And you can check that I'm allowed to tell you to do this because on the chain it says that I am, right? So the challengee can check, okay, well, yes, this guy did get the challenge and I am the challenger, or I'm the challengee, and so I should transmit this. And then that device transmits out the radio, and anybody who sees that packet can then say, aha, I saw that packet, I want to be a witness. And the challenger is sitting there and it's aggregating the receipt from the challengee and then any witnesses that come in. Again, this is subject to, you know, maybe the packet got corrupted on the radio, maybe the witness can't dial the challengee or challenger, whatever it is, right? These are all sort of probabilistic. We assume that they work most of the time. They're, you know, any particular challenge, a lot of stuff can go wrong. But essentially at that point, when the challenger figures it's gotten enough information, then it's going to bundle all that information up and publish it on the network as a receipt and say, here's what the challengee said it did, and here's what the witnesses saw. And that's broadly the roles of the different components in a challenge.
Cool. We're coming up on the hour. Actually, we're right at the hour. There's one more question in the chat, which I'll go ahead and throw at you. If you had any visibility into how this week's cold weather has affected the Helium network, whether we've saw an uptick in usage or particular outages, things like that.
You know, that's a great question, and I don't have an answer. I mean, Abai might have an answer. He might be able to. I don't have anything directly. I think.
But that's actually a really interesting question, and I'm gonna figure it out. Like, it's
so
actually possible to figure that out.
I remember a couple of years ago when the Helium network was absolutely tiny. You know, we had our friends PG&E do rolling blackouts in the Bay Area, and we were worried it was going to halt the chain because we hadn't really expanded out of the Bay Area at that point. So, you know, like certainly, I think that the network as a whole doesn't have enough in Texas to take it down at this point. Like we intentionally try to keep the consensus group geographically separate from each other. And I believe the Explorer now has an update. You can see the map of where the current, you know, nodes making blocks are. And you know, we can tolerate whatever, a third of them being down at any one time. So unless more than a third of them are in Texas, I think we're okay, or in the Midwest, I guess, because Texas is particularly affected. But and actually with validators, we want to grow that number much larger. We would like to have a consensus group up in the 30s or 40s or even higher. Part of the work we want to do with this validator testnet is to see how far we can push the existing you know, mechanisms to see how far they scale. Like we've run a couple of years ago, we ran a testnet of 37 nodes, and they were all in the group. And we've made some improvements and performance fixes, and there are more coming. So I'm hopeful we can get, you know, 40, 60, something like that. It would be huge from a resilience standpoint. You know, it'd be truly a global network at that point, which would be really, really amazing. But yeah, I don't have any numbers on Texas, this Texas event especially, and it's not really over yet. But it would be really interesting to try to do some data science there to see if there's any sort of interesting fallout from that.
Cool. Yeah, I think we are at time. If you have anything else you want to close out with, welcome to do that. Oh, I can hear myself. That's weird.
Oh, sorry. I couldn't hear
Otherwise,
myself.
it's same time next week. We've lost Travis. He would do his thing, but yeah, thanks for joining, everybody.
Thanks, Professor.
Thank
I mean,
you.
I can stick around a little bit longer if it looks
Well,
like we have a couple of questions.
I got one question, real quick. If I was had all the money as far as the nodes and creating the validators and all that part wasn't an obstacle, the part about the knowledge base and what does that really encompass when you say you should really know what you're doing or something like that when it comes to running the nodes, I guess.
So we are trying to build, and I'm going to show my age here. I am before the era of Dockers and containers and such things, but we are trying to build it such that you can basically just spin this thing up, and it should more or less run itself. The things that you know, like having sort of basic systems management experience, like I can deploy a service on probably a Linux machine, right? I can deploy a service on a Linux machine. I know how to check if it's running. I know how to look at the logs. I have like basic command line familiarity. Is sort of I think what we're targeting, right? Is like, you know, you have some basic operational knowledge, which in a way is harder to come by these days. You know, like back in the day, you know, you know, people would run their own email server, they'd run their own database server, they run their own web server. You know, again, we've sort of been lured by the siren call of centralization, and so not as many people, in my experience, know how to do that anymore. But you know, we're as I said, we're working fairly hard to make it. I think it's some kind of container or Ansible script or something that basically it should do most of the work for you. And your role is really around, if something goes wrong, you have some troubleshooting abilities, whether it's I can go get at I can look at the logs, or I can run commands, or I can check the network is working, like the disk isn't full, like that kind of basic stuff. It's not like you don't need to know what elliptic curve Diffie-Hellman ephemeral key exchange is, or you know, and you don't need to know any of that stuff. It's more just like basically, here's a system that needs network, disk, and CPU, and your job is to keep it happy.
Yeah, and to add on that, we are going to be shipping Docker images similar to what we do today for the for DIY, and you know, you should be comfortable with sort of basic network security. These things do have a key on them, and that key can be used for bad things, right? For someone to taking away your validator, and so it is sort of important to know about that, and sort of, you know, one, like have the right firewall ports open for the blockchain to work, but then also not make it completely open so anyone on the world can come pick it up and run away with it. So
yeah.
And you know, there will be tools that allow you to, let's say your server is compromised, or let's say your wallet's compromised, you can transfer your stake and do things like that. But and you know, the unbonding period, right now proposed is 5 months, but we might come back to that. You know, will protect you somewhat, but it's something that you just need to be like very comfortable with. But yeah, no, you don't need to know the intricacies of the blockchain to run one of these validators. You need to know that one of those things is running and sort of what ports need to be open and things like that.
A quick question on the testnet. Are you looking for folks that are, you know, say running or signed up to run 5 validators to also run 5 on the testnet? Is there sort of a hope that the testnet will have sizable similarity to the final network?
Yeah, we definitely want a sizable testnet. Also, during the testnet period, we want people to break it, and we'll talk about things. You know, once it gets stood up, like we'll talk about things that one could try to do to take it down. In fact, it would be great if we could take it down while we're operating the testnet, because we want to make sure that we're resilient to those kinds of, I guess in this case, white hat attacks.
Sorry, I have one quick question. It's kind of open-ended, but can I ask it?
Yeah, I think
You
we're
can
just
ask
kind of
it.
hanging
Yeah,
out.
we're in bonus hour, right? So
Yeah. So do you think that Helium, just as a network, maybe or maybe not using LoRaWAN in the future, has like potential applications for providing higher bandwidth internet service, like for providing higher bandwidth internet service for like an average consumer, not just for commercial use in IoT? Or do you think that's technologically possible with the state of LoRaWAN?
LoRaWAN is never going to do that, right?
Right.
The protocol is absolutely not designed for that. But we talked about this a little bit earlier. I think that there is absolutely room for doing Wi-Fi or 5G over a network like this, right?
Yeah.
I think that that's absolutely tenable. It's going to take some work, but I don't think that there's a technical reason that it couldn't be done. I mean, obviously, the existing players in the field have no interest in building a network like this, so there's not really been any consideration made in the protocols or in the clients of these networks. But I don't see why we couldn't do it like that. You would basically be probably buying chunks of bandwidth or something like that as a user. Well, we'd have to think about it, think about exactly how that all fits together. And I know there are people working on it. So, like clearly there's an appetite for networks in this mold, right? The idea that you can provide coverage, but you own a piece of that network. You're not just, being exploited by AT&T. You're a co-owner in that network, and you can put up coverage wherever you want, right?
So like as a
You don't have to
consumer,
justify it to AT&T.
so like
What?
as a consumer, you would hold equity in the blockchain or something like that, or you would stake.
Oh yeah, or you just have hotspots and you're making money out
Right.
of providing coverage in your neighborhood, right? You've got the best coverage in your neighborhood, and people are like, well, I've got it, maybe I don't need an internet connection myself, right? I'll just and of course the ISPs are going to fight you here, and they're going to say, oh, you're reselling service, and so there's a probably more legal hurdles in the way here than there are technical ones, because obviously ISPs don't want you to resell their service, which is kind of silly because they're basically utility. It's like the power company saying you can't sell your power that you buy from them to somebody else, or you can't sell your water to somebody else, right? If you've already paid for it or you're paying for it, they shouldn't, in my view, be able to tell you what to do with it. But if you read your ISP contact agreement, there's going to be all kinds of stuff that they shoehorned in there. So you have to be careful of that kind of thing. But if you had commercial grade internet or commercial, yeah, I think they tend to not have those clauses in there. So maybe one guy pays for commercial Comcast and provides coverage to the whole neighborhood, right? And in theory, that's hard for Comcast to say, well, don't do that. But like you could imagine that, or even just bringing internet to places that currently it's too expensive. Like underfunded or underprivileged neighborhoods. If you could give people data for $5 a month instead of $50 a month, that's probably a game changer for a lot of people.
Yeah.
So yeah, I think the potential's there. There are some technological and legal hurdles in the way, but I don't think that they're insurmountable.
Okay, thank you.
I think that might be it. Travis probably already has plenty to edit through in his recording here. So
Gonna huddle around the computer while it's rendering the final video.
got to get heat somehow, right?
Yeah,
doing it in 4K just to stay warm. Awesome. I'm going to hit the end button. If it kicks everyone out, I apologize, but not really. So.
And Joey, thanks
Okay.
a lot. And Andrew, thank you very much for joining us and doing this AMA tonight. Thank you, everyone who's joined. And
Thank you.
next
thank you
week,
so much.
same bat time, same bat channel. Take care, folks.
All right, bye. Thank you.